Dan Olds here, 2025. It is another Winter Classic Invitational Student Cluster Competition Studio Update show, and we are talking to one of the teams from Channel Islands. Actually, more officially, I believe, California State University Channel Islands. And this is Team Nautical Processing. How you doing today?
Good. How are you doing, Dan?
I'm okay. It's fine. It's okay. I'll get through it. A lot of stuff going on, but enough about my problems. Let's talk about your problems. Let's see. I'm just gonna say two words and see what your association is with them. Oak Ridge. How'd that go? The Quantum Challenge.
Well, Oak Ridge started, we started off pretty, I feel like after our meeting, we started off pretty organized, but as time progressed through the week, it became clear because of our schedules and conflicts and because of the limited time frame on the IQM resonance, we weren't able to complete task two, and it just, over time, it became more disorganized, and
it was no question about that, was the toughest challenge in this, and the most advanced. It's not easy to wrap your head around quantum computing. Anybody had any experience with quantum at all before this? I'm gonna say no. Anybody had a chance to run on a multi tens of millions of dollars quantum system before that? No. Yeah. Let's see. I know you've had your quantum 101, 201, and 301 classes, right? Have you completed those?
no.
Dr. Feaster hasn't fired up a whole quantum series yet?
Yeah, not. In one of Dr. Feaster's classes, he did give us the chance to work on a sort of quantum assembly assignment for about a week.
Yeah.
Yeah.
Well, that must have gotten you all the way there then.
Oh,
So, yeah. Has anybody told him that what you guys are doing about the quantum thing? Because I think he would be shocked.
does anyone know?
Somebody ought to just tip him to that you guys have actually run on a piece of Frontier, which is pretty cool, and then an actual real quantum system. I think he'll think that's pretty cool. No other cluster competition's ever done that before, by the way. None of them. No one's run Unreal Quantum. So it's a first. Yay. Okay. Anybody in the room answer this? It's a jump ball question. What's been the hardest thing about the competition? Yeah, somebody in the back there. You're sitting in the back for a reason. It's smart, but it doesn't work. Yeah. Oh, yeah. Yeah. We've narrowed it down to you too. Yes. It has been narrowed. It's sort of locked in there.
Uh, at least for me and Emily's, we were experiencing login difficulties with AWS. And so we couldn't really do the tasks at hand sometimes.
Okay. Okay. And I guess that this is as good a time as any also to follow up. How did you approach the AWS thing? I mean, for the viewers at home, the AWS challenge was, on the face of it, running WRF, the weather and climate application, but really it was about how to set up a cluster and how to pick the right components for that cluster to get as much performance as you can at the lowest price. So what was the approach? Walk me through it.
So what actually helped more than anything for that AWS challenge was actually videos from the test, because we kept referencing
Really? Okay.
What we found is
you broke up a little. You kept referencing
the videos from the test. So those were the most helpful material because we had to basically try to optimize how many P threads we're going to use, how many OpenMP threads as well. And what we found out as the videos mentioned, you get to a certain point where you just can't use any more OpenMP threads.
Mm-hmm.
You hit a peak eventually, and
Yeah,
when we found that peak, we decided to just stick to those numbers.
because that's the thing is that you can throw more cores at it. It's just not going to use them. And you need to find out where that inflection point is, right? And then, and I would think that you take a look at what that point of diminishing returns is and decide, hey, wait, we can shift our choices down to nodes that have less than that number of cores, which is going to shift your price down as well, right?
Yeah.
Yeah. Good. How were did you do any profiling of the application at all? Do you know what I'm talking about?
Not necessarily.
Okay. That was in the videos too, but he didn't talk about it a lot. But this would be the first thing that you would do is get yourself a free profiler or a fancy one. They're out there. And what a profiler does is it will, you know, look at your code as it's running and monitor what it's using in terms of CPU, memory, interconnect, all of that stuff in a granular way over time. And that's also related back to the steps in the application. So you can see where the bottlenecks are. In fact, some of them will even tell you, this is the bottleneck, fix this. And that makes the job, what you did kind of by hand, makes it a bit easier. Does that make sense?
Yes.
Yeah. Yeah. The other thing in the AWS is that you had to do a handover, sort of like a disaster recovery. How did that go?
So for the first part, it was Julian who mostly set it up. Right before the AWS, our cluster got wiped, he did write simple instructions on how he managed to get around it based on the instructions that were provided. I was the one who decided to rebuild the cluster, and I think it only took about 18 minutes total to just
Not bad.
rebuild everything and basically get the result that we had previously.
Good. Good. Now, did you work on getting a better result from there, or do you think you'd gone as far as you could?
Well, we always try to get that better result, but we
Hmm.
with the first portion of the challenge, we optimized this as much as we could. We were still experimenting with enabling and disabling things,
Hmm. Hmm.
but for the most part, we just couldn't get past our previous result. So we do believe that we optimized it as best as we could.
Okay. Now, there was a time limit in that you had your runs to be valid, had to be under 4 minutes and 30 seconds. How far under 4 minutes and 30 seconds could you get?
I think we started by just slowly changing variables within the shell. That brought us down to, I believe, 2 minutes 40. And then we try to see, okay, we changed some OpenMP threads. Let's try to
Mhm.
the way the P threads are counted. From there, we managed to get down by maybe 4 or 5 seconds. And at that point, we realized, okay, with the shell script, we did all we could. Now it's time to get to the actual file. And when we worked on the file, we managed to get down to, I believe, 2 minutes.
No way. Really?
Yeah, around 2 minutes.
Huh. That's interesting because the mentor, Evan, who's pretty good with this stuff, he got around, I want to say 3 minutes, 10 seconds with his best shot. I don't know. But that's That's something. That is something. Um, Excellent. Okay. So let's go around the room. And yes, I am going to make you talk, Emily. You don't want to, but I am. Um, but let's go around and just ask a little bit about what you think you got out of this. And actually, I'm going to start with you, Emily, because we're getting towards the end of the competition. So what did you get out of this? And you can say nothing.
I think I just got exposed to more of this material from my teammates and following along because they're definitely more knowledgeable on what they're doing. So I would just like kind of ask questions. So it was kind of like an introduction to
Yeah.
high performance computing for me.
Pretty harsh introduction, but sure. Yeah. Harsh, fast. Yeah. 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 Okay, let's just keep going clockwise from Emily. You are up. What is next? What did you get out of this? No, clockwise. Actually, clockwise, my view would be the other way because we're reversed. Yeah, there you go. No, Emily's got him. No, next to Emily, on Emily's left. Yes.
Oh, to piggyback off Emily's answer, I definitely got a lot of information on how to run these sort of things using the Urban Google Doc that he made. I was able to see the parameters he was changing, and it was very interesting seeing like how he changed the threads and some of that stuff to get like a lower time.
Yeah. Yeah, it makes a difference. Yes. Yes. And I mean and also I'm talking about the competition in general, not specifically the AWS stuff. So keep going. Who's next?
So for me, I guess what I got more out of this is how similar, almost similar, these clusters operate. Because you're gonna start at roughly the same spot. It's all about how are you gonna optimize the cores that you have available, the threads that you have available.
True, true. It's also making sure that you have the right proportion of stuff available. And that's where something like the profiling works out because you've got CPU cores, you've got memory, you've got IO, you have those basic things. And if you're doing HPC right, the last hurdle you'll hit, the last bottleneck is memory bandwidth. And that's the one you can't fix. You can paralyze your heart out, but you can't get past memory bandwidth. And so that's sort of a old school rule of thumb. Okay, next up, what have you learned? What do you know now that you didn't know back on January 12th?
I feel like I learned a lot about how high performance computing works. Like everything's at a hardware level. You're very much focused on the CPU and like how you're designated all the processing cores and everything. I learned a lot about that. And just like just working with actual computer, high performance computer through Linux and creating batch files, doing all that. That's very new to me. I had never worked with that before.
Was this your first real experience with Linux?
Kind of.
Okay. So you had some, right?
Yeah.
Yeah. But that's good. Did anybody use the Linux tutorial we had up online? We got one. Okay. Good couple. Okay. Was that helpful?
Mm-hmm. Yeah, it was.
Okay. So I should keep that in for.
Oh, yeah, definitely.
Okay. I think so too, because there are not a lot of schools that I've found that have a Linux class that's hands-on. So good. And while I'm asking, what about the videos, the stuff from the Pittsburgh Supercomputing Center? Good, helpful.
Yeah.
Keep it in.
Yeah, I think so.
Okay.
I think it should be kept in as a somewhat of a tutorial into the supercomputing because once you watch at least two of the videos, because they are long. If you watch at
Oh
least
yeah, yeah.
one of those videos, mainly the first one and maybe one of the other ones,
Hmm.
will help you understand more about how the supercomputing in general operates.
Yeah, you're absolutely right. In fact, I'm toying around with a couple of ways to do that. Um, One thing is that next year's folks will have the ability to use the supercomputer that they use for their exercises. So you'll be able to do them kind of in lockstep, not live, but you'll be able to do them. The other thing is maybe having a requirement that you gotta watch, the first two or something like that. Um, Problem is it's hard because these teams always assemble late. Um, I start talking and get schools committed to it in like September, but I don't get team lists until December, and then they change in January. It's hard. It's hard. So, last one, Devin, you want to move over so I can see you a little bit better? What were your learnings?
Oh, so my learnings were, well, first of all, this is the first time I've ever done anything high performance computing. So the first benchmarks we did, I was learning pretty much almost everything about it from scratch, learning how to run queue jobs, run the scripts, make the scripts.
Even how to log in and all that stuff, right?
Yeah, so
Yeah,
I did all that, and then a few models or the next model. I think since our program is mainly here C and C++, I learned since we were making Python scripts, I learned a lot about Python as well and graphing with Python and importing modules and stuff like that as well, and as well as everything that was said before with changing parameters, finding bottlenecks, learning about
sure.
you, and yeah.
Good, 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 good. And um, all of this stuff that you've learned and experienced, it's going to come back in weird ways and help. But the first thing it's going to help on is when you're doing interviews for positions that, you know, the interview questions always come up. What was the hardest thing you've done in computing? What was a tough situation that you had to figure out? You have those now. Each one of you has those war stories, whether whatever you did worked, you were triumphant or not, you have the stories, and the stories are what is going to get you to the next step. Because if you're just in kind of classroom stuff, you don't really have those. So there you go. And actually, before we close this out, I imagine you want to know where you are because all the scores have not been released. I've been backed up on processing all that stuff. You know that you did good in LinPack. First thing you did, you were fifth. Nice. HPCG, second. Nicer. You came out of that first module fourth. Going into the next module, which were the videos and the HPC crash course, um, you did well on the points. You were fourth in terms of right, wrong answers. You were a bit slower on the time. Your final sort of blended time and points, you were sixth, which was good. And you came away from out of that one, you were ranked third overall. Right up there, eh? Then we got to the quantum challenge. Quantum challenge made a difference. You were eighth on that one, but that's a don't feel bad eighth because there were, a lot of teams that didn't turn in anything. And you also, I can tell you this, you doubled the Barracudas score. So there's that. Um, but because of what you had done before, right now, this is before AWS, you're fourth. not too shabby. I would be happy with that. You're fourth with a shot at getting higher. You're only 30 points or so, 30 and change behind Santa Cruz. So yeah, um, you look good. This has been successful for you. You've done really well. And there's still 200 points out there. Um, you have the Pittsburgh Supercomputing Challenge. That's gonna be reasonable. It's not something out of like Oak Ridge where they're always pushing the envelope. This is going to be fairly conventional. You'll be using some GPUs. Yay. Um, and that briefing will be coming around probably, I don't know, I haven't heard from him. Monday at the latest. Um, then after that, we'll start to do the team interviews with the judges, which are scary, but they won't be that scary. What you want to do is just present what you've done and keep that down to about 20 to 30 minutes. Make sure everybody participates, and there'll be questions from the judges, and make sure everybody kind of answers. And it's not bad, not hard. And actually, you can kind of make some contacts from those too, which is nice. Sue, I think that's it. That's all I got. You guys have anything else? No? No? Should we go ahead and just call it an interview?
Absolutely, that'd be great.
Let's call it right now. Okay. Well, thank you out there, everybody, for watching. Get with us on social media, as you'll see on your screen right now. And you know what? Why not follow this thing? You're not doing anything better. You're just sitting on your computer right now looking at social media. Why not click that follow button? Yeah, do it now.